Hey developers, Stefan here coming at you with another LeetCode problem. This problem is number 819, the most common word. We're going to be given a paragraph represented as a string, and we're going to be giving a list of banned words. We want to check all the words in the paragraph string and figure out which one is the most frequent that is not in the banned list. Some clarifying questions we're going to need to ask for this is, do we count punctuation? Is everything going to be lowercase? Is there going to be mixed casing? In which case we need to set everything to lowercase so that we can actually count the frequency correctly. We're also going to want to ask, what is the format of the words in the banned list? Are those all uppercase? Are they specific casing, or are they all lowercase? Otherwise we'd have to format the paragraph and the banned list the same. Here in the problem definition, we can see that words in the list of banned words are given in lowercase. So we're probably going to want to make the paragraph completely lowercase before we do the parsing on that too. The initial thoughts I have around this is that we can split the paragraph by spaces and then count through everything and put them in a dictionary where the word is the key and then the count is the value, and that should get us to a working solution. Let's start coding that up and see if there's any edge cases we haven't completely thought through yet. So we'll just brute force this and then determine what the complexity of it is, if it is the most optimal, or if there's something else we can do. So as I said before, we're going to want to make the paragraph to be lowercase. We're also going to want a list of punctuation to ignore. Probably not really a list. We probably want to define a set because the set has O1 lookups. Whereas if it was a list, we'd have to iterate through it each time to determine if a character is in the thing. So let's ignore punctuation. Hopefully our interviewer would tell us which ones to ignore. All right, we got our set of ignored punctuation. Another thing we need to consider is if the paragraph will be given numbers, like represented as numbers, or if they'll be spelled out as words. Because if you have like 1 space and then the word 1, does that actually count as like 2 ones, or does that just count as whatever? If we assume that the paragraph is defined as just letters and no numbers, and the letters are separated by spaces, kind of like a basic paragraph, then we don't need to really worry about that. And that is actually what is true in the notes for this problem. After some experimentation, I remembered that strings in Python are actually immutable, so you can't like substitute just plain strings. You have to use something like the replace method. But with the replace method, that operates in ON time for each different thing that you're replacing. And since we have 5 characters in our ignore list, we don't really want a 5 ON thing. Instead, we can use the re library to do a replacement. So we can do paragraph equals re.sub, and then our pattern is anything that includes the question mark, exclamation point, comma, semicolon, and period. I know these strings are a little hard to read. I apologize with that. And then we're going to want to replace it with an empty character. And then the thing that we're going to be looking at is this paragraph. I actually didn't want to do that. Oh my gosh, horrible. Paragraph. And then we will print the paragraph with this line to make sure that those characters have been removed. All right, so we can see the comma is not in our standard out, neither is the period, so this is doing the right thing. This means that this re.sub is more optimized than iterating through this, and in which case we don't actually need this anymore. So to go ahead and get our frequency count, we're going to want to get a list of all the words. So words list equals paragraph.split on the space key. And then what do we want to do this? We want to filter this for the things that are in the banned list. What's the most optimal way to do this that isn't n times x? All right, so thinking about this real quick, there is actually a m plus n way to do this instead of an m times n way to do this. So we can convert band into a band set, and this will equal set band. And then frequencies. I think there's a way that you can actually just use Python to convert this into a frequencies dictionary. But if we do that, we won't be omitting the banned words. So let's just do this manually. For word in words list, if word not in band set, actually this isn't n plus m at all, this is n. And actually, I think if we use a priority queue instead of a dictionary, that might give us a faster lookup than having to look through the frequencies again at the end. We could potentially use could we use something else to determine what the max is? Let's just try to do a max word, and we'll store this in line. Yeah, this might not be the most optimal, but I think it will work. And it's at least better than, is it? Yeah. So what I'm debating on doing here is keeping track of the max word as we look through the paragraphs. We can also do this at the end as well in a separate loop. All right, after thinking about it, I think we're just going to do the toList way. So then that'll be 2on. We're requiring additional space for our frequencies dictionary and also additional space for our words list. But that's all just on as well. Anyways, if the word is not in the band set, then frequencies max word. Actually, what we also want to do is if word not in frequencies, frequencies max word is not what we want to do anyways. That was wrong. Word equals 1, else frequencies. Why is this not auto completing for me? And then we'll increment the value by 1. This should populate our frequencies list. And then once we have that all populated, we'll iterate through the frequencies dictionary for word count in frequencies.items. If max word equals null, max word equals word. If count is greater than, I'm not sure what we should do if we have two words that are the same count. So if hit and ball or both occur twice, does it matter which one we actually return? We'll look at that in a second, but if count is greater than frequencies max word equals word. And then we should just be able to return max word. Go ahead and run this. Invalid syntax, obviously this needs to be a double equals. Hopefully I didn't do anything like that anywhere else. All right, Bob hit a ball. The hit ball flew far after it was hit. So we are omitting the punctuations. We're splitting everything into a list of word frequencies. We're populating a dictionary if that word is not in the band set that we converted. And then at the end, we go ahead and reiterate through our frequencies dictionary to figure out which one is actually the highest. We could keep track of that as a running count, but I didn't see much advantage to doing that over just counting it again at the end and doing a double pass through the list. It isn't actually truly 2ON because frequencies is smaller than the number of words in the paragraph. This looks like it's accepted. Should we go ahead and just submit it? I am slightly concerned about the case where max word, there's 2 of them, but we'll go ahead and submit it. Wrong answer. All right, obviously this was a thing I did not expect. All right, this is actually a really good edge case because our resub is just converting these commas into empty characters, so to actually end up joining BBC. I guess all we need to do to fix this is make the resub a space. That's something we should have wanted to clarify or thought about a little bit more before we went ahead and added this code in line. But I think this should just take care of it, and we'll see if we run into any other edge cases. Hopefully not. And we did. All right, what do we do here? All right, so after a little bit of time debugging, I realized that if we were doing resub with spaces here, once we substituted out the comma with the space, we would have ball, space, space, the, and then when we do the split method, it was actually changing that to a empty character represented by what we defined as the max words. And that count was actually higher than the occurrences of the word ball. So once we got to this line, we would set this for the frequency after doing the regex substitution, and then we would end up switching it to the last value, which just happened to be the. To fix this, if word not in band list and word is not equal to the empty string, then we go ahead and add in the frequencies. This ended up fixing the problem, so we verified that by copying over the test case that we got wrong into our little console here, and then we could see that that was accepted. Let's submit this now. And still more wrong answer. Interesting. All right, let's look at this new case that we're running into. We definitely should have thought through this a little bit more and walked through some edge cases. All right, and this error was just because we weren't looking at the apostrophes. Adding the apostrophe into the resub check made it so that this was accepted as well. These were some pretty kind of careless mistakes that if we spent more time looking at it, we should have definitely been able to pick that up. Let's try and submit this. All right, we got success. The runtime is faster. The memory usage is less than 100%. I think the memory usage is kind of bugged right now. But anyways, this runtime faster than 84%, that's definitely ideal. And I think that's because we were converting sets. We were doing things in line to keep things as a couple sequences of ON operations. Let's go ahead and verify this by looking at some of the other answers that we have in here as far as runtime goes. It looks like the runtime distribution isn't that big on this problem, surprisingly, but all right, looking at this problem, it looks like this is a little bit slower because we're doing 2 different researches in this list comprehension, and then we're doing another for loop here. By doing the substitutions in line and only looking at that once, you cut down on the chance of this being an ed squared operation. All right, and that is this week's LeetCode operation. If you like these problems, please like and subscribe to the video. Definitely try to do some weekly LeetCodes. If you have a specific LeetCode problem or another coding problem that you'd like me to work through, leave it down in the comments. I'll be happy to give it a try. I hope you all have a nice week. Take care. Bye.